So we'll learn two other very interesting keywords and ideas in loops called break and continue. These are super useful. We'll see why they're useful with the prime number example again. So let's see what happens. Let's see how break and continue behave. Okay, here is your flowchart for those of you who like to see flowcharts. This is also very interesting example. So for example, whether we are in a for loop or in a while loop. Okay, suppose if I say, okay, if I do something like this, if I say at some point, if I say break, okay, if your interpreter executes break, it will directly come out of your, so this is your for loop body, right? This is the body of your for loop. It will directly come out of your for loop body and execute code which is outside the for loop. Okay, similarly for break in if else conditions, sorry, in the while loop. So this is the body of your while loop. If you say break, it means come out of the for loop or the while loop. Just come out of your loop structure or break out of your loop structure. That's what it means. Okay, so this is visually very interesting. So it tells you as soon as break runs, where does your Python interpreter start running next. So this is code outside the for loop. Similarly, in a while loop, it directly comes outside the while loop. So here it's coming outside the for loop block, right? So let's see an example that will make it much simpler for us. Okay, let's see. So imagine if I have a list of 1, 2, 3, 4 numbers and I'm iterating over the list. I'm saying num in numbers. If number equals to 4, break. Okay, so what will happen first? First, my num will be 1. This condition is not true, so it will print. So it is print 1. Now 2. That's what it's iterating, right? Now my num becomes 2. Now my num was 1. Now it will become num equals to 2. Is 2 equal to 4? No. So it will just print this. So if it's not true, this is the if condition, right? It will not go into this, right? So print num, it will print. Similarly for 3. As soon as num becomes 4, if num equals to 4, break, which means it ran this, num equals to 4, true, it comes here. As soon as it sees break, it will say, oh, this whole thing is my for loop, right? For with an else here. This is important. So it will directly come outside the for loop and print, and it will start executing from this line, right? See, it is also skipped the else. That's important. It has also skipped the else part in your for loop. Okay, it's directly come to outside the loop because it looks at this whole thing as one logical chunk. Okay, so break is very useful. Let's see an example for the Python, for the program to detect whether a number is prime or not, right? We saw this example, right? We saw this example where I'm making only one change here. I'm making one simple change here, nothing else. I'm just putting a break here. So what am I doing? If a number is divisible, right? If let's say I enter, let's say 16. Okay, let's assume my number is 16. Okay, I'm iterating this from 2 to 15, from 2 to 15, right? This is what I'm iterating, right? Because I equals to 2, I less than equals to num, and I'm incrementing I by 1. Okay, which means I got 2, 3, 4, so on, so forth, 15. Now, 16 percentile 2 is 0. As soon as that becomes 0, I'm saying is divisible equals to true, and I'm printing that, okay, so and so number is divisible by so and so number, and I'm saying break. So as soon as break happens, what happens? Now this is my while loop, right? I'm going to come out of my while loop and print it. What's happening here is earlier we were checking all the numbers 2, 3, 4, 5, so on, so forth till 15, right? Which means we are actually doing this, we are running this loop 14 times because there are 14 elements here, right? 1, 2, 3, 4, so on, so forth, right? If you count number of elements here, there are 14 elements. 15 minus 2 plus 1, right? There are 14 elements here. But by using the break, as soon as I find any number which divides it, I'm saying come out because I know it's not a prime anymore, right? So by using break, instead of running this loop 14 times, okay, if your num equals to 16, that's what I'm assuming here. If your num equals to 16, okay, you're going to run this loop 14 times. Instead of doing that, as soon as I find some number which can exactly divide your num, come out of the loop and say it's not a prime number. This is much more efficient, right? Because instead of running it 14 times every time, as soon as I find a number, I'm going to come out of it. Okay, of course, I might find it at the start, or I might find it at the middle, or I might find it almost at the end. That doesn't matter. But break is making your code much more efficient, where it's saying, okay, don't run through this loop 14 times. Just run through it as long as you don't find a number which can exactly divide it, which means it's improving the number of times you run your loop. By the way, for a lot of programs in modern computing, a lot of time is actually spent in loops. So almost 80% of your code typically spends time in 20% of your code, which is mostly your for loop code. 80% of the time is spent here in loops like this, right? So if you can reduce the number of iterations by using break, you're making the time that it takes to run this program much lower, right? So let's just quickly run this so that there are no syntactical errors. Sorry. Okay, so here is the code. Let's run this. Okay, so if I enter 19, what's happening? It's saying it's a prime number. If I enter, let's say 16, what happens? Oh, it says it's not divisible by, it's divisible by 2. So it's just taking the first one. It's saying it's divisible by 2, and hence it's not a prime number. I don't care if 4, 8 other numbers also can divide. I don't really give a damn about it. Okay, because it's divisible by 2, I'm going to come out and say it's not a prime number. Okay, this is where break is extremely useful, where you want to come out of it for efficiency reasons. There is another type of construct or keyword called continue. Let's see what happens in continue. Instead of the flow chart, I'll take you through this very interesting example. So what continue does is very, very interesting. So for example, if as soon as your code goes and runs continue code, runs the line which has the keyword continue, instead of so break takes you out of the loop, right? This is the structure of the loop, right? This is the block where your for loop is executing, and this is the block where your while loop is executing. What did break do? Break took us out of the loop. Continue will take you to the next iteration of the loop. It will not execute anything here. It will not execute anything that is after the continue. It will directly take you to the next iteration in the loop. So it says continue running the loop without running anything which is below me, if you want to remember it that way. Continue the loop. Okay, let's look at here. Okay, suppose if I want, this is actually a very, very simple example. If I want to print only odd numbers, okay, so I'll say for num in numbers, which means it will go through all of them. If number percentile 2 equals to 0, continue. So what happens with 1? 1 percentile 2 is 1, not equal to 0. So it will never come into this continue. It will print the number. It is print 1 here. Okay. Now next, see what happens for 2 when num equals to 2. When num equals to 2, 2 percentile 2 equals to 0. So it will say continue. As soon as it continues, it will go here. It will now take your num to 3, which means it has not printed this, right? So that's why in the output, you don't see 2 here, right? You want to print only the odd numbers in the list, isn't it? So whenever this condition is satisfied, whenever it's an even number, continue. Don't run this line, because this whole block is your for loop, right? But what happens is after all the loops are over, it will still go and print the else loop. It'll go and execute the else block. So it went through 1, 3, 5, and it's running the else block. Remember, your break even comes out of the else part. We saw that earlier, right, in this example. So in this example, as soon as you said break, it didn't even print this line. It directly came and print this line. So break takes you outside even the else part. Continue, on the other hand, takes you up. Instead of taking you out of the loop, continue will take you back to this part. And it says, okay, don't run anything which is below me. Okay, just go up and keep doing it. And after everything is over, else will run as is, right? That's a simple example. So break and continue are extremely important constructs in your loops. So today, in these discussions, in the sequence of last 3 discussions or last 3 talks, we went through what a while loop is, we went through what a for loop is, and we went and understood what is break and continue. These are extremely useful constructs in any major programming language. And Python makes it much more elegant and simple and easy to write, especially through ideas like indentation and simpler syntax with the keyword in here.